let's create a formula for geometric series. So we'll do it a similar way. If we write down all the terms, we'd start at a plus ar squared, all the way to ar to the n minus 1. I'm going to rewrite it, but this time I'm going to multiply it by the common ratio. And you'll notice I've also shifted the terms there to make it a little bit more obvious why I've done that. So now I'll get r times the sum to n is ar plus ar squared, and so on and so on. So if I think of this as simultaneous equations, we're going to get the subtraction, and all those middle terms are going to cancel, the ar with the ar squared, and so on, leaving me with r minus 1 lots of sum to n is ar to the n minus a, and we come up with our formula. Sum to n is a r to the power of n minus 1 over r minus 1. We tend to use that if our ratio is greater than 1. If it's less than 1, we swap it round. Notice how it's now 1 minus r to the n over 1 minus r. Now all we've really done is multiply top and bottom by negative 1. It's the same formula. And then we tend to use that if the ratio is less than 1. Now why do we do it? I guess it's just so that we get a positive number on the bottom of a fraction. If you've got a number bigger than 1, then r minus 1 is going to be positive. If you've got a number smaller than 1, then 1 minus r is going to be positive. It doesn't really matter which one you use. If you're okay with a negative number on the bottom, you can use the same formula for everything. It's totally up to you. Okay, let's find the sum of the first 10 terms of this particular pattern, 2, 6, 18, and so on. So the first term's 2, our ratio is 3, and we have 10 terms. So subbing in, 2 times 3 to the power of 10 minus 1. Well, we got lucky with this one because, of course, the bottom of the fraction, 3 minus 1 is 2, and that will cancel with a 2. 3 to the power of 10 minus 1, there it is, 59,048. Here's one in sum notation, but I recognise it to be a geometric one because now the n, the variable, is in the exponent. And we said geometric ones will look like exponentials. So, okay, knowing that, oh, hang on, they're not starting at 1. So I've got to be careful with that. The first term then is 6 times a half squared, sub in 3. Now the ratio is still a half, but, well, if you don't believe me, you could always sub in n equals 4 and just confirm that, oh yes, it is multiplied by a half. But at the end of the day, there's your general term. So you know half is the ratio. And what we talked about before, 8 minus 3 is 5, which means there are 6 terms in this one. And if you're unsure, use your hand. 3, 4, 5, 6, 7, 8. Oh, look, 6. Okay, let's sub it in. I'll use the 1 minus r formula this time because of the half. Now, calculators are great, but depending on how it handles this or not, you might like to work all the other stuff out first. So 1 minus a half is a half, so I've rewritten this as 3 on 2 times, and then I've worked out the 1 minus a half to the power of 6 separately. That's 63 and 64, and then I've inverted and multiplied the half, and then from there I get a nice, neat calculation. Mind you, as I say, calculators these days are usually pretty good to work all that out in one hit. 189 on 64. Okay, that'll do us.